Okay. Yeah, welcome back to the second hour. Now, before we proceed, I wanted to just talk about the test for this week. Right after the class last week, there was a message on in the Microsoft Teams where one of you said that you have discussed internally and you would prefer 11 o'clock on Saturday, which is October 2nd, uh, instead of Thursday evening. Is that correct? Thursday evening is actually tomorrow. Is that a consensus from the class, or that was just someone trying to, or who has spoken only to a very small group? Guys, I need an answer here. Otherwise, how I will just go ahead and schedule the test as per my plans. Is anyone here?
Yes, sir. I'm sorry, I just came back from the break. Could you repeat?
What I said is, I had, as per our initial plans, the class test is supposed to be tomorrow evening, but I received a message saying that you have discussed as a group internally and you would like to have it on Saturday morning. I wanted to know that if this is a consensus from the class, or is it from us? Is it the representation from a small group? Because Saturday is a national holiday, I I cannot force an exam on that day unless the request comes from the whole class. Then it means that and you have agreed, or rather you want it.
Saturday is okay.
No, but that's just one
Sir, is
person
there any
speak.
chance? Sir, is there any chance if it could be in a weekday next week, because we like tomorrow 8 to 9 we already have another paper, uh, and on Sunday morning as well. So is
No,
there any
sorry,
chance it could be?
no. I had announced this at least 10 days back that it is going to be this week. You cannot. You should have.
So
Hmm. You
okay,
cannot
sir. So
pick.
you're
We
saying
cannot.
Saturday morning?
That's what you wanted. Saturday is a national holiday, so I cannot force an exam on that. I had initially said Saturday without realizing that it was October 2nd. But you guys had pointed out saying that no, it's a national holiday. So I moved it to Thursday. That was last week itself during a discussion. So what
So
would you
then I
want?
think the original plan is okay.
Original plan is tomorrow. Okay, is that correct?
Yes, sir.
Any other views from the rest of the students here?
Sir, Saturday is fine, sir.
What about the others?
Yes, sir. Saturday is fine, sir.
Yes, sir, Saturday is fine.
Yes, Saturday is fine.
So Saturday is fine.
Okay. So Saturday morning, I'll let you know the time. You have asked for 11 to 12. I will see it can be 9 to 10, 10 to 11 as well. I'll have to look into I think I have another meeting on Saturday morning. I'll check and get back to you. So you have to be flexible on Saturday morning, okay? And again, I'm putting it on record that it was a request from the class to have it on 2nd of October. Okay. So please do not complain against me saying that I'm forcing an exam on a national holiday, because that's what you requested. Okay. All right, then Saturday morning it is. I'll let you know of the time. Process remains the same. It will be a pen and paper test, as we call it. So like a conventional test, the paper will be made available to you at the time of at the start time of the test. You will have either 45 minutes or 1 hour to complete, and then another 10 minutes to upload, to scan and upload, that is. Okay. All right. So let's move on and go back to radiation. What we were discussing is pretty interesting, which is we are trying to find out what is the radiation exchange between two surfaces. And while doing that, we are still talking about black surfaces. But while doing that, what we figured out is there is something called shape factor, which is an extremely interesting concept, has some very interesting properties, and which can be used while calculating the heat exchange between two surfaces. Okay, so let me start sharing my screen now.
Sir, can you please explain once again why the reverse of the additive relation is not true?
I did not explain, you think about it. You take any geometry, okay? Let's try it out ourselves. Let us say whatever surface 1 doesn't matter. Surface 2, I break it up. So this is surface 3 and this is surface 4. So the shape factor from 3 to 1 is what? The double integral A3 A1 or yeah, cos beta 1 cos beta 2 pi L squared sigma right dA3 dA1. Therefore, 4 to
So
1.
the sigma part won't be a part of the shape factor, no, sir?
Yeah, that is okay. This is the integral inside. Okay, this is the shape factor actually. dA3 dA1 will go in, and then sigma t to the power 4 t1 to the power 4 will stay out, and the rest is the shape factor. Okay, that's fine. Oh yeah. Oh, okay. I know what you're saying. Sorry. Yes, you are correct. Yes, you are correct. I thought I was writing Q3 to 1. This would be 1 over A3, right? And then integral A1 or A3 A1, whatever, cos pi L square dA3 dA1. Similarly, 1 over A4, whatever A1, A4. Okay. Now, can you add this up? Because in one case you have A3, the other you have A4, isn't it? What was F2 to 1? Would have been 1 over A2. Then this, whatever. A1 is fine. This would be A2. Yeah, I know dA2 can be broken up into dA3 plus dA4, right? So I can split it out and say that, okay, this part I can break up. But the problem is one of these, it is 1 over A3, the other is 1 over A4. I cannot break up 1 over A2 as 1 over A3 plus 1 over A4, isn't it? So that is why
Yes.
these two cannot be, these are not additive. On the other hand, if it was 1, 2, 3, then everywhere we would have had 1 over A1 here. Then I could have broken it up. This is from the mathematical point of view. Physical point of view also, you can see that what is being emanated from 3 goes everywhere else, and part of it comes to A2, A1. Same for A4. Okay, so it's not necessary that these two, whatever is given out from A3, the fractions will add up to that of A2. And mathematically, you see it here. Okay, so anyway, this was a side exercise to tell you. Okay, let me conclude it here. Therefore, F2 to 1 is not equal to F3 to 1 plus F4 to 1. All right. Let us do a problem. The problem is, and this is where we will see, okay, the problem is that this is a surface. Sorry, I did not draw it well. Sorry. This is another surface. This is A1. This is A2. And I'm asking you to find what is F1 to 2. How will you do it? Okay. So what you can see here is, this is essentially what it is, okay. If I extend A2, then it reaches, you get a combination, let's call this as A3. You get a combination of the known configuration of two perpendicular rectangular plates. Okay. So what can I write? I can write F1 to 2 as F1 to 3 no, sorry, A3 actually, or let us consider this as A4, sorry, okay, that's fine. A1 to 4 minus F1 to 3, right? The additive relation. Because if I extend this and say that this entire A3 plus A2 is one surface A4, then I can write F1 to 4 is F1 to 3 plus F1 to 2, right? Can I get this? Yes. Can I get this? Yes. Okay. Both of this can be obtained from standard charts. Okay. I could have made this more complex. I could have given you, sorry. an area like this, let me call it A0, and I can ask you, what is 0 to 2? How will you do it? Okay, try this out. Try this as homework. It's simple. You have to just go through a few more processes, but it's possible. Again, using the additive relationship. What else can we do? Let us do one more problem. I have another one here. Let us do what I just told you. Calculate the shape factor of the inner surface of a cone with respect to itself. So what am I saying? I'm saying that this is my surface. Somebody's mic is on and there is noise coming in. Okay, now when we define a cone, we need to define some parameters at least, okay? We need to define either what is the height and radius or what is the height and angle, whatever. So let us define those. Let us say this is h, and this is angle alpha. This would be h tan alpha. How would you do it? I'm saying that this is my surface 1. And I'm asking you to find out what is F11. So how will you do this? Anyone?
So probably we can consider base and name it as 2. And then if
Excellent.
12 plus F11 is 1,
Excellent.
F21,
Excellent.
F22 is 1, and F22 is 0. And then the reciprocal relation, we can find F21 and F12.
Got it. Very nice. You have to close the base. So now why did we do this? Think about it. What is emitted from 1 will either reach itself or it will escape through the base. So if I close the base, then what happens is becomes a two surface enclosure. Okay. So then this is, as I said, a two surface enclosure, which means F11 plus F12 is equal to 1. F21 plus F22 is also equal to 1. But F22 is 0. This is a flat surface. So therefore, if 2 to 1 is 1. That's obvious, isn't it? Because whatever is emanated by 2 has to reach 1. So therefore, now what you use is you use the reciprocal relation as correctly pointed out. Therefore, F12 will be A1 by A2 into F21. No, no, sorry. Other way. A1 F12, so this is A1 and this is A2. F21 is 1, we know, so therefore A2 by A1. And therefore F11 is equal to 1 minus F12, therefore equals to 1 minus A2 by A1. And A2 by A1 is sine alpha. Okay. If the radius was given, A2 would have been pi r squared, and this would have been what? The surface area of a cone is pi r L, and L is h by tan alpha. And tan alpha is r by h. Okay. Okay, so either way, even if the radius was given, you could have found it out. So these are some of the ways that you can calculate shape factors, and from there you can calculate what is the radiation exchange. Okay. Now what I will do is I will skip all these. Now there are lots of these problems that you can find in any textbook. I will also upload the problem sheet for radiation. But now let us move on to heat exchange between gray surfaces. Okay. Now what I will do is I will right now, I think maybe the other sections also will start with a definition called radiosity, etc. I will hold on to it for now. And what I will do is I'll teach this portion through examples. Particularly one example to start with, which is heat exchange between, let me not write down everything. Of course, heat exchange between two infinitely parallel surfaces, gray surfaces definitely. Okay. Now earlier when we defined two surfaces, it was just the temperature and area. Now I have to define a third term, which is emissivity. And as I said, unless otherwise defined, we will consider surfaces to be gray and diffuse. Remember, we had mentioned that. So this is epsilon1 A1 T1 and epsilon2 A2 T2. Okay. So what are the assumptions? Infinite in all directions. So these are parallel, and then what essentially infinite means is f1 to 2 is equal to f2 to 1 equals to 1. Okay, infinite flat surfaces, number one. Number two, gray, diffuse, opaque. So therefore, what can we write? From Kirchhoff's law, we can write alpha 1 equals to epsilon 1 and alpha 2 equals to epsilon 2. And since they're opaque, we can write that the reflectivity is 1 minus epsilon 1 and rho 2 is 1 minus epsilon 2. Okay. Now, one thing is, it is obvious that Q1 over A1 is equal to Q2 over A2. Okay. Sorry, not Q1, Q over A1. So the net exchange between these two surfaces per unit area are also the same, because the areas are the same. That's it. Okay. Instead, if these were like two concentric spheres or cylinders, we could not have written this. But because these are flat, we can write it. Okay. We can also know from Stefan Boltzmann law that E1, which is emissive power, is epsilon 1 sigma T1 to the power 4, and E2 is epsilon 2 sigma T2 to the power 4. True. Again, look, we are using all these tools in our toolbox. So now what we will do is, look, I'm going through something which is not necessary, but I will still go through this because this will give you the physical feeling of what is actually happening. Otherwise, there is a shortcut method which I'm going to teach you later, which is called the radiation network method. But for now, I want to go through this process, even if it takes a little time, because you'll be able to understand and appreciate what exactly is happening. Okay. Okay. So this is my surface 2. So what I'm going to say is, let us consider from here one ray. Consider a ray E2. Okay, please note that this ray is representative of any other ray in all directions. So consider a ray E2 emitted by A2 that reaches A1. Right? So let us track this path. This is E2. It reaches A1. What will happen? These are gray surfaces, so not everything is going to be absorbed. What is going to be absorbed? E1, E2. So I can write epsilon 1 E2, sorry, epsilon 1 E2 will be absorbed, and 1 minus 1 epsilon 1 E2 will be reflected. Very good. So let it get reflected and come back. What is this? 1 minus epsilon 1 E2. As it comes back, what happens? Epsilon 2, 1 minus epsilon 1 E2 gets absorbed, and one minus epsilon 2 times 1 minus epsilon 1 times E2 gets reflected. Okay. Again, when it goes here, this epsilon 1 times 1 minus epsilon 2 times 1 minus epsilon 1 times E2 is absorbed. And what is reflected? One minus epsilon 1 squared times 1 minus epsilon 2 E2. Agree? Then that comes here, and what do you have? You have again epsilon 2 into 1 minus epsilon 1 squared times 1 minus epsilon 2 E2, and so on. Okay, so let me write down here at surface A2, epsilon 2 this gets absorbed, and 1 minus epsilon 2 1 minus epsilon 1 E2 gets reflected. Okay, so therefore this series continues. So let us write it and see if I can find a pattern. This will be an infinite series, so I can write radiant flux emitted by A2 and absorbed at A1 is equal to what? Epsilon 1 E2 plus epsilon 1 1 minus epsilon 2 times 1 minus epsilon 1 E2 plus epsilon 1 1 minus epsilon 2 squared 1 minus epsilon 1 squared E2 plus dot, 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 dot. Okay, so what is this? This is an infinite series of terms. It's like 1 plus x plus 1 plus x squared plus x cube, etc., to infinity, where x is less than 1 because both 1 minus epsilon 1 and 1 minus epsilon 2 are less than 1. So I can write it as epsilon 1 E2, take it out, 1 plus x squared plus dot, 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 where x equals to 1 minus epsilon 1 times 1 minus epsilon 2 and is less than 1. Right? So what is this infinite series? We know epsilon 1, epsilon 2 divided by 1 minus x to the power minus 1 right? You can further simplify it as E2 epsilon 1 divided by epsilon 1 plus epsilon 2 minus epsilon 1 epsilon 2. Okay, Similarly, if you had taken a ray from surface 1 and traced its path, gradient flux, okay, emitted by A1, and absorbed at A2 would be just symmetrically epsilon, no, this is epsilon 2 E1. So epsilon 1, no, गलत करो, epsilon 2 E1 or E1 epsilon 2. Let me, yeah, this E and epsilon are sometimes confusing. So E1 epsilon 2, and the denominator will be exactly the same, epsilon 2 plus epsilon 1 minus epsilon 2 epsilon 1. Okay, therefore net gradient exchange flux, of course, Q by A or Q double prime 1 to 2 will be how much? The first one is the second one minus the first one. So this is what it is emitted and absorbed at E2 minus the other one is what is absorbed at A1. Okay. Now what is E1? Sigma T1 to the epsilon 1 T1 to the power 4 blah blah blah. So what you get is sigma epsilon 1 epsilon 2 T1 to the power 4, sorry, T2 to the power 4. Nah, क्या कर रहा हूँ? T1 to the power 4 minus T2 to the power 4. Okay. Or Q over A 1 to 2. I can write it as sigma T1 to the power 4 minus T2 to the power 4 divided by, and look at this, how elegant, 1 plus epsilon 1, 1 over epsilon 1 plus 1 over epsilon 2 minus 1. So this is the final closed form expression. It's a very well-known expression that everyone must know. Okay, now enough of your sigma A T to the sigma epsilon A T1 to the power 4 minus T2 to the power 4. Remember this expression. So remember the shape factors are all 1, which necessarily doesn't be A1 and A2 are equal. And whatever is emanated from 1 has to be intercepted by 2 and vice versa. So this that way was a simpler problem. Okay, but what this does is this gives rise to a very important concept called radiation shield. If you look at spacecrafts, for example, if you think of a spacecraft, okay, and what happens is you want to retain the heat inside because outside it's extremely low temperatures and it's not convection because at space is rarefied atmosphere. So radiation is a major mode of heat transfer. So what is done is they use radiation shields. How can I reduce this further? So we will see this later, that if you put a thin material between these two plates, which is known as the shield, what happens is it goes a long way to bring down this whatever heat exchange. Okay. So in tomorrow's class, we are going to cover that. Okay. Tomorrow we will try to conclude. We may need one more lecture, but we'll try to conclude everything tomorrow. Conclude radiation tomorrow. Okay. Thank you very much once again. Yes.
Sir, tomorrow you are taking exam at 9, 8 to 9, right?
I thought we just decided that we are.
Sir, can you do it in in theory class, because
Sir, many of us have test of CDC and all that.
sir, ये वाला week बहुत loaded है sir. Like there were
Guys, I don't know where you were at the beginning of this lecture itself. In the second hour, we decided that the class test is going to be held on Saturday morning. That was a request that came from you guys, from your classmates, and that is what we have decided. Okay, I don't want any further discussions on this.
Sir, can you do it 9 to 10 Saturday, 9 to 10 morning?
Okay, that is possible. Okay, so in that case, unless we are deciding here, class test will be on Saturday morning 9 to 10. That is finalized, frozen, and no further discussions on this. Okay. And guys, please don't come back with I'm a little disappointed this way. Ye week loaded hai, etc. Don't give those excuses. Because this test was announced at least 10 days back. You cannot come back the day before the test, that as per original schedule, today is the day before the test, and ask for postponement. In real life, these things will never happen. So please don't make unreasonable requests like this. I know CDC is important, but this is also important. Load to life में लेना पड़ेगा भाई. When you go for a job and if there is a product release, what would you say? I'm loaded and I cannot do the release. You will have to, just like you have several courses, you will have multiple projects to balance, and you have to do that. Okay. Thank you. See you tomorrow, 9 a.m. Sorry, 10 a.m. Thank you. Bye.